We're going to look at section 2.5. It's a continuation of our discussion on linear functions, and we're going to talk about a new form of a line called the point-slope form. Now, in previous sections, we looked at the slope form of a line. The slope form, if you'll recall, is this form where the slope is equal to y2 minus y1 all over x2 minus x1. It's the rise over run of your graph, okay, or of your line. Well, now if you have a line, and let's just set up sort of a very basic illustration. So here's a line. If I were to give you an individual specific point, like say the point 1, 3 or something like that, you could find that point on the line. From that point, you can get the rest of the line using the slope, okay? Get your rise over run and so forth. And so every other point is a variable point because it changes. The second point would change, okay? It depends on what you're using as your rise and your run. So the initial point here, I'm going to call that x1, y1. But the second point, because now this could be any point along the line, it's called an arbitrary point. I'm going to call that just simply xy, okay, because it's now variable. It could slide up and down. So I fix a point, that's the one given. The other one is one that just slides up and down and traces out the rest of the line. So it's a variable because it changes, okay? And then I'm going to give you a fixed slope, all right? So the reason we call this the point-slope form is because you're going to be given a point and a slope. Those are fixed. The rest of the line then is what you're trying to determine. Okay, so I give you the point, I give you the slope. You are going to be trying to figure out an equation to represent the rest of the line. Okay, so let's think about that. If I were to plug these 2 points into my formula, essentially what happens is the y2 and x2 just become y and x respectively. And so the subscript of 2 drops off. Not a big deal. It's a similar equation. So we use m equals y minus y1 over x minus x1. Okay? Now, we talked about this back in chapter 1, that anytime you have a fraction in an equation, and I'm going to try to solve, get my y's by themselves here, just kind of get y's on one side of the equation, everything else on the other. When you try to get rid of a fraction, you multiply by the least common denominator. Well, here, the LCD is just the denominator. It is a bit complicated because it has 2 terms in it. But I can multiply both sides by that expression. So I'm going to multiply the right side by x minus x1. I'm also going to multiply the left side by x minus x1. Okay? So I'm multiplying both sides. Then, on the left side, I'm going to rewrite that a little bit, just change the order. So I have m times the quantity x minus x1. We typically like the binomial, or the 2 terms, parentheses, to the right and a constant on the left. It's just a standard, but it doesn't matter because we're multiplying, so the order doesn't matter there. Then we're going to set that equal to, now on the right side, the denominator cancels out, and we're left with just y minus y1. And now, of course, usually when we solve for a variable, we like to have that variable on the left side. It's just more common to do that. And so I'm going to switch the 2 sides of the equation around and write it as y minus y1 equals m times x minus x1. This is what we call the point-slope formula. Okay, it's a nice formula that I can use when I'm given a point and a slope. I can plug those two things in for the x1, the y1, and the m, respectively. Okay. Then once you've plugged in the three values, you solve for y, get y by itself, and you'll have a slope-intercept form, a nice y equals mx plus b sort of format. Let me give you an example of how that works. So if I were to, we'll keep that formula up there. If I were to give you simply a point and a slope, let's say the point is 1, 3, and the slope is -2. Okay, so let's say the line is going to go through this point 1, 3. It's going to have a slope of -2 going down to the right. So all I have to do is substitute those three numbers into my three variables, x1, y1, and m, and I got to get them in the right spot, right? So this is x1 is the 1, y1 is 3, and of course the m is -2. So I plug those in. Here's my formula, so I'm going to have, maybe I'll rewrite that as well just so it looks nicer here. So I start with y minus y1 equals m times x minus x1. My y1 is 3, so we get y minus 3. M is -2. And x1 is 1, so I have x minus 1. Alright, so I'm just filling in the three values. At that point, I'm going to solve for y. To do that, I'm going to distribute the -2 on the right. We have y minus 3 equals -2x. Double negative there in the second term gives me a +2. And of course, to solve for y, I've got to add the 3. So I'm going to do that. Add 3 to both sides. And y is going to be -2x plus 5. Okay? This is going to be my slope-intercept form of the line that goes through the point 1, 3 and has a slope of -2. Now, from this equation, I can already tell, because it's in the form y equals mx plus b, I know the slope is -2. Well, that makes sense because that's what we were given. I also know that if I plug in a 1, think about this, plug in a 1 for x, remember inputs and outputs here, -2 times 1 is -2, plus 5 is +3, right? -2 plus 5 is 3. And so 3 is the output when you plug in 1. So that means this point 1, 3 is on the graph of this line. So I've now created the slope-intercept form of a line. Two main characteristics. One is that it goes through the point 1, 3, means that point is on it, and it has a -2 slope.